Hi everyone, welcome to LearnNCode. We are learning Python programming. In the last session, we have seen the concept of indentation. We have discussed that the main purpose of indentation is to indicate the block of code. Though we are using indentation for improving the readability in all programming languages, but we use specifically to indicate the block of code in Python. That's the main use of indentation. And also we discussed various rules for using indentation. And in today's session, we are going to talk about the data types in Python. After completing the basic data types, we are going to implement the Python concept practically by using the Python IDLE and also the command prompt. So let us discuss the various data types in Python. So before moving on to the various data types in Python, you should know what actually meant by the data type. Data type mainly indicates the type of value we are going to store in a variable, the type of value we are going to assign to a variable. The type may be integer or float value. What type of value we are going to store it depends on the type of the data. So we have various data types in Python. The first data type in Python is none. And the second one comes under numeric, the second data type. And third one we are going to talk about is, just wait. Now we will discuss various data types in Python. Before moving on to the types of data types in Python, let us have a discussion. What do you mean by the data type? The data type mainly describes the type of value we are going to store in a variable. The type of value we are going to store in a variable. Specifically, the data types can be divided into the first one we are talking about is none. And second data type is numeric. First one is none and second one is numeric. And third one we are going to talk about is lists. And fourth one is tuple. Instead of saying lists, we can say only list. And fourth one is tuple. And fifth one is set. And the sixth one is string. And the seventh one is the range. And the eighth one is, we call it as a dictionary. Total how many data types in Python? 8. First one none, second one numeric, third one list, fourth one tuple, fifth one set, sixth one is string, and seventh one is the range, and the last one is dictionary. There are 8 data types in Python. Now we are going to see none, after that numeric. Depending upon the time and depending upon the situation, wherever it is required, we are going to discuss all the data types in Python. First, let us discuss the first data type, none. What does mean by none? Actually, the meaning of none is null. We have used the concept of the null in C programming. When there is no value to give, when the value we don't want to mention, then that is nothing but none. For example, I'm using a variable a. I don't want to store any type of value in the variable a, then simply you can mention here none. Simply it is a null. Don't think that the value is 0. It is not 0. Nothing we are giving to the variable, that is known as none. After this none, next we are going to second data type, that is numeric. Numeric data type. Numeric data type in Python. Numeric data type broadly divided into first one, integer data type. Here we are talking about integer data type. After integer data type, next we have float data type. After this, coming to third one, it is complex data type. Complex data type. And fourth one we are going to talk about is boolean, or we can say bool data type. So these are the 4 data types which comes under the numeric. First one is integer data type, second one is floating point, third one is complex data type, and fourth one is bool. We are going to discuss each and everything one by one, which comes under numeric data type. The first one we are going to talk about is integer data type. Integer data type. See here, the integer data type is going to contain the integer values, or we can say the decimal values. For example, here we write -2, -2, 3, 1, 4, 5, 6, plus 2, 1, 3, 4. These are the different integers that we can store, and the type of these values comes under integer. Now, so the main important thing is, please remember, in Python, there is no maximum limit. Whenever we talk about C programming, in C we have the various types of integers like short integer, next we have long integer, right? So due to the range problems, due to the size problems, we have different type of integer, short integer, long integer. But in Python, there is no limit on integers. You can store any size of integers in Python without specifying this integer about the size internally. This is very, very important. You should know in Python. So all are comes under only one type of integers, and you can store any number of values or any number of digits. There is no maximum limit for the integer data type. Now, how to represent integer data type? So for representation of integer data type, we can use different type of notations. First one is we can use the decimal notation, and second one we are going to talk about non-decimal representation or non-decimal notation. Non-decimal notation. Decimal notation in the sense we are going to use the base 10. Base 10. Generally, for example, if I write an integer 123, so here it comes under by default the decimal number whose base is 10. Why the base is 10? Why? Because we are going to use the digits from 0 to 9. That's why we are mentioning the base. Actually, when we use the concept of decimal number system, there is no need to mention the base explicitly. Just we write the numbers like 123 minus 123, no need of mentioning the base. So generally we represent the integers by using the decimal notation. Now we are going to see how to represent the integers by using non-decimal notation. Here we are talking about the non-decimal notation. Non-decimal notation. See here, if you want to represent an integer by using non-decimal notation, what to do? First we are going to talk about the binary representation or binary number, or we can say binary number system. And second one, we are going to talk about the octal number system. Octal number system. After octal number system, we are going to talk about the last one, hexadecimal number system. Hexadecimal. Now we will see how to represent an integer using non-decimal number system. First, we are going to talk about binary number system. Binary number system. To represent an integer by using binary value, what we do is we add 0 small b or 0 capital B as prefixes. That means, for example, I want to use the binary number 0101. I want to represent the integer in the form of 0101. So before this, what you have to add? You have to add 0 small b, or we can say 0 capital B 0101. We can use 0 small b or 0 capital B as prefixes to use these binary numbers to indicate an integer. Okay. So whenever we run the Python code using the command prompt, so generally whenever we work with the command shell or Python shell, we will get this prompt. At this prompt, whenever we give 0 small b 0101, then what is the output we are going to get? We are going to get an integer. What is the integer value that we are going to get whenever we give 0 small b 0101? What is the value you are going to get? That is very, very important. Now, whenever we give non-decimal number system with the base sum n, and we have to convert that non-decimal number with the base n to the decimal number system with the base 10. This is very, very important. Now we have given the value 0, 1, 0, 1. We have given this value 0, 1, 0, 1 to this command prompt. Now what it is going to do is it is going to convert this non-decimal number or binary number to the decimal value. How the conversion will be taken place? So take the number 0, 1, 0, 1 here. Now you move from right to left. That means most significant bit to least significant bit, and the base is 2, right? This is the binary number. Here, what is the base we are using? 2. Now you start from 2 to the power of 0 and 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So after this, you add the values. How to add the values? First, you start from most significant bit, 2 to the power of 0 into 1, that you write 2 to the power of 0 into 1 plus 2 to the power of 1 into 0, 2 to the power of 1 into 0 plus 2 to the power of 2 into 1 plus 2 to the power of 3 into 0. So what is the value we are going to get? This becomes 1. To do anything to the power of 0 is 1. 1 into 1, 1 plus 2 to the power of 1, 2. 2 into 0, 0. Just we are summing up. Next, 2 to the power of 2, 4. 4 into 1, 4. And here last one becomes 0. So what is the value here we are going to obtain? The value we are going to obtain is 5. That means when we say 0b 0101, the output we are going to get is 5. 5 is what type of value? Decimal value. That means internally we are converting the binary number into the decimal value that we are going to get is 5. This is the way of representing the integer in the form of binary. This is the first case. Now, second one, we are going to talk about how to represent the integer in the form of octal number system. Octal number system. Now, you do one thing here. Again, you start with the 0, but here you write, instead of using small b, you use small o. Or we can use 0 and capital O. This O represents octal. This first one indicates 0. I'm differentiating 0 from O by writing like this. By giving a line inside the circle, we are representing it as 0. Now, for example, take the command prompt like this. Now, here I'm writing 0, O, small o or capital O you can give, 72 I'm giving. So, what is the value you are going to get after pressing enter? See, what is the number here? We are taking 72. We are representing integer in the form of octal, that is called 72. Now, what is the output you are going to get? If you want to know the output of this, what you do is take the number 72, which is represented in octal, and do the same process just now we have seen. Now, 72 you take and you move from right to left. So, what is the base for the octal? 8. Why? Because we are using the digits from 0 to 7. Now, you start from right to left. What you do is you take 8 to the power of 0, and here it is 8 to the power of 1. Now, again, do the same thing, 8 to the power of 0 into 2 plus 8 to the power of 1 into 7, that equals to 8 to the power of 0 being 1, 1 into 2, 2 plus 8 7 is 56. That means you are going to get the value 58. See, whenever you give 0 small o 72 and whenever you press or hit enter key, now we are going to get the value 58. This how we are going to represent the integer value 58 in the form of 0 72, which is in octal. That is very, very important. Now, after this octal number system, next we are going to talk about the third one is hexadecimal number system. Hexadecimal number system. See, in the hexadecimal number system, what you have to do is same thing you have to do. Take 0 and you write small x, or you do one thing. Take 0 and you can use capital X. You have to use these two as prefixes. You can use capital X or small x. Take the same command prompt. Assume that you are taking 0x and you are using FF. FF. So hexadecimal number system. When we talk about hexadecimal number system, we are going to take the values from 0 to 9 next to A to F. That means of the 10 in hexadecimal number system will be represented by A. That means we are taking from 0 to 9 digits, 10 digits. After that, 10 is represented by A, next to 11 is represented by B, C is 12, D is 13, E is 14, and F is 15. So we are taking the digits from 0 to 15. That means totally 16. That's why the base for the hexadecimal number system is 16. Now when you take 0xFF, what is the output we are going to get? See, to see this again, do the same process. Take F, you can use capital F or small f. Again take F. What is the base for F? 16. You start from 16 to the power of 0, 16 to the power of 1. Now again do the same process, 16 to the power of 0 into F plus 16 to the power of 1 into F. That is equals to anything to the power of 0 is 1. F means 15. Please remember, F is nothing but 15. You replace F with 15. 15 into 1, 15 plus here 15 into 16. What you have to write? It is 15 into 16. 16 to the power of 1, 16 into 15. 16 into 15, how much? 5 6 are 30, 5 1 are 80, right? 1 6 are 6, 1. Here 14, 240, right? So this is 240. That means 240 plus 15, 255. The answer you are going to get here is 255. This how we are going to represent the integer. That means 255 is the integer, its equivalent hexadecimal value is FF. This how the conversion will be taken to represent the integers. So still now we have seen how to represent an integer. So the ordinary way is to use the decimal number system, but by using binary number system and hexadecimal number system and octal number system also we can represent integers. Now after that, the second data type we are going to talk about is floating point or float data type. So float data type means here we are going to store the real values. Real values. That means 23.45. Okay. So this is the general way to represent the floating point number. Not only this, we can also use another notation that is called exponent form. Exponent form. That means, see, we can represent a real value like this 23.45 into 10 to the power of 2. So same real number can be represented as 23.45. So E2. You can use E2. That means 23.45. You can use small e or you can use capital E. Capital E2. Both are valid. This is another representation of float data type. Not only this, we can use the data type like this 23.16 into 10 to the power of minus 2. That means 23.16 e minus 2 or capital E you can use. These are the different ways to represent a float data type. So after this, we will see the next data type that is called complex data type. What do you mean by the complex data type? Under complex data type, we are going to take the real part and imaginary part. You know how to represent a complex number. See, in Python, the complex number can be denoted by like this, a plus b j. And a is some value and b is some value. The imaginary value is represented by using the value by the letter j. J means to represent the complex part, imaginary part. See, the general value, you know that j equals to minus 1 under root of minus 1. See, a value you can take any value. For example, I am taking 2 plus 5j. This is the way of representing the complex number. To represent this type of complex number, we use the data type complex data type. After complex data type, next we have the data type called bool or boolean data type. The boolean data type is going to take two values. One is true, another one is false. Here, very important thing you should know here is first letter must be capital. T must be in capital. Very, very important. Now, F must be in capital. If you don't write T or F in capital, we will get error in the Python, right? If the condition, for example, you take some condition, if I said 2 is greater than 1 colon. If this condition becomes true, its internal value becomes true. If it is false, it is going to take the value false. Now you can ask one doubts. When you use the concept of true false for the Boolean data type, why you have included in the numeric? Numeric means we are going to take only the integer type related values, right? So here we are not taking true and false. See, don't think in this sense. What you do is even though you give true, false, they are internally converted into true is converted into 1 and false is converted into 0. If you can convert them into integer, so that we can get 1 and 0. So bool also comes under the numeric data type. So with this, we have completed integer data type, float data type, complex data type. After that, bool data type. Next, we will see the string data type. Okay. With this, I'm going to close the session. Thank you for watching.